All right, up next, I'd like to introduce our next speaker, Saeed Bukari. Go ahead.
Thank you.
It should be good.
Just hit next. Okay. Hello. Okay. Hello, everybody. My name is Syed. I'm a PhD student at the University of Toronto, and I'm going to be sharing a bit of my recent work that's come out of a collaboration with the OGS. And I'd like to acknowledge one of my co-authors, Abigail, without whom this work would not have been possible. So to kick things off, unfortunately for you guys, glacial land systems are one of the most complex sedimentary systems in the world. They have a huge amount of lateral and vertical heterogeneity, and that obviously poses challenges in mapping for hydrogeological and geoengineering studies. But we're scientists, we don't leave it at that. We don't give up, and we generate models. So what we propose in this work is something termed a depositional systems approach. And a depositional system is classically defined as a three-dimensional package of sediment with varying facies, but that are genetically linked. And they're bound top and bottom by unconformities. So in Southern Ontario, obviously, the principal depositional system is a glacial system. And what you can find within the subsystems within the glacial systems are subglacial, glacial lacustrine, glacial fluvial. So at any given point, you have an interplay of these processes generating a very complex stratigraphy, each with their unique lithologic and hydrogeologic properties. And speaking of this, these sediments, this figure might be familiar to some of you. This is the distribution and thickness of glacial drift in Southern Ontario. And we can, at first glance, it may seem random, but it's actually, there is a method to this madness. The sediment is localized in bedrock valleys, very old bedrock valleys that Abigail pointed out earlier. And we've used data from these valleys, data collected by the OGS, in conjunction with outcrop data to generate a depositional systems model for Southern Ontario to make your lives easier. And in this model, we've used the principal stratigraphic units from the Scarborough Bluffs area to generate a composite stratigraphy of Southern Ontario. And now we get into the meat of it. So there's a lot of information on this slide. I'm going to start on the far right side. What we have there is a time distance diagram. And this time distance diagram, it's basically describing the advance and retreat of the last ice sheet during the Wisconsin glaciation. And this advance and retreat is genetically linked to the sediment facies we have in Southern Ontario, which you can see right beside it in the stratigraphic log. And we've subdivided those into 7 principal depositional systems. And just to reiterate, these depositional systems have varying facies, but they are genetically linked. So at the very bottom, in the green and the yellow, we have tills from the penultimate glaciation, and in the yellow is a period of a warm period of deposition. So we have warm climate warm climate fluvial and lacustrine sediments. And then we get into the early Wisconsin, which is the longest phase of the Laurentide ice sheet in Southern Ontario, and that's reflected in the thickest packages of sediments. So the early Wisconsin is responsible for the deposition of depositional systems 3 and 4, which are in red and blue. In depositional systems 3, we have ice distal glacial lacustrine fine grained facies, and obviously they are interbedded with finer silts as climate changes. And depositional system 4, we have coarser sands as the ice grew thicker and advanced further into southern Ontario. And on the right-hand side, this is schematic diagram of what that ice might have looked like, where it might have been. So it would have been blocking the St. Lawrence, and it would have had a huge proglacial lake where these sediments would have been deposited. Moving on, we arrive at the last glacial maximum. This was about 20,000 years ago. The last glacial maximum is characterized by depositional system 5, which is a regionally extensive, very thick glacial till. And one of the important things to note here is the flow direction of the ice sheet. It was generally north-south and extending well into Ohio. And following that is the deglacial phase of the Laurentide ice sheet just after 17,000 years ago. And this is when we have probably the most important phase of deposition, where as the ice is melting, it becomes highly lobate, the flow directions change, and it's highly influenced by topography. And this is when we have the deposition of depositional systems 6 and 7, which are namely large came moraine complexes such as the Waterloo moraine, as we can see on the figure on the right. And this rapid deposition occurs through a mechanism called ice streams. So when we have a big dome of ice over a continent, it will have conduits or arteries of very fast flowing ice. These are called ice streams, and we can recognize these ice streams now in Ontario with that delicious LiDAR we have now. So their beds are easily recognizable because they're marked by these highly elongate ridges of megascale glacial lineations. And this is just an image of what they look like. On the left is a Peterborough area, Highway 7 and Rice Lake, for those who are familiar. And on the right-hand side is on the escarpment, just south of Owen Sound. We have the big Walkerton moraine and obviously another ice stream bed. And all of that just to say that these large moraine complexes, interlobate moraine complexes, are deposited by converging ice. So I'm just going to revisit this last slide to summarize things here very quickly. And show you a cross-section of these depositional systems across southern Ontario. So we'll be starting near the Ipperwash Valley, where X is, and moving through towards Y. Okay, so few key things to note here. We obviously have the thickest successions of sediment in where we have the bedrock valleys. And these are directly related, for those with very short memories, to the paleoglaciology. And last thing to note here is, actually in my next slide, these depositional systems rationalize the complex stratigraphy of southern Ontario. They provide an easy framework for specialists and non-specialists to navigate the complex stratigraphy. And And most importantly, they provide a regionally cohesive and coherent framework for hydrogeological and geoengineering investigations. And obviously, no talk would be complete without plugging my own work. So if you'd like to read more, we have a recent publication in CJES where we discuss this subject in detail. Thank you.